Good morning, everyone. Thanks for joining us on our IFS training webinar. So first up, a quick introduction. My name is Fiona, and I'm in charge of marketing and specification at IFS Coatings. And I've been working in powder coatings for about 12 years now. I'd also like to introduce you to Jason. Say hi, Jason.
Hello, my name is Jason Parton. I'm an application engineer with IFS Coatings, and I've been working in the powder coating industry for about 23 years now.
Great. Okay, all right. So these webinars have been designed to help train professional coaters on many different aspects of powder coatings. Now, we fully appreciate that there are many coaters out there with years of experience who are doing a fantastic job. And we also know there's many who are always looking to learn more, pick up tips, ideas, suggestions, that type of thing from other powder professionals. We also realize that there are coaters looking for help in training employees or new staff. We actually get asked about that quite a lot. Or maybe simply want to expand the knowledge base of existing staff. So obviously we can't cover every subject, question or query, but hopefully in this series of webinars we'll address a lot of the common questions that we get asked. So we thought the best place to start is with the basics. So this first webinar will cover the different types of powder coating.
So people often simply want something powder coated. And they just ask for powder coating in whatever color they want. They really have no idea that there are different types of coatings, that some coatings are better in certain situations and things of that much. They just know they want powder. So there are several different chemistries or types of powders, not just brands. So each type or chemistry brings certain advantages and disadvantages to the coated part. This webinar will look at the most common types of powder coating, their advantages and disadvantages, and typical applications. Hopefully this will help if you're not aware of all of them. It will provide a refresher if you are. And as we move through the webinar series and we refer to these different product types in later presentations, everyone will be on the same page.
Great. Okay, so before we get into the different types of powder coatings, let's review some of the basic characteristics of powder in general that any powder type or chemistry, whatever you want to call it, will bring to the coated part. This type of information is great for any coater to pass on to their own customers so that the customer or the end user knows what the coated finish is going to deliver to the piece. One of the great advantages of powder coating, especially when you compare it with most liquid coatings, is that it's tough, durable, and scratch resistant, and it still looks great. A really good finish is achievable by any coating professional. Powder can be applied on any type of powder line, from hand applications to fully automated, with all sorts of different brands of equipment and over different forms of pre-treatment and even onto different substrates. When you apply powder, what happens to the powder is essentially the same. So the powder is electrostatically applied to a grounded part. It's cured in an oven. The heat in the oven melts the powder and causes it to cross-link over the surface of the part, which gives it the tough, durable, and protective film. And powder also has some key mechanical, chemical, and weathering properties, regardless of product type. And Jason's going to take us through some of those.
So as Fiona said, the advantages you can see here on this slide are pretty general. And in fact, most of the different product types or chemistries display these characteristics. Powders are known for their great film integrity, hardness, and scratch and mar resistance, especially when you compare them with competing liquid coatings. I know that's one thing we constantly hear from general contractors, especially when they've only worked with liquid coatings in the past, is that then when they get items that are powder coated, they don't have the dings and scratches and mars that they normally see with the liquid coating. It's also worth pointing out that because it's a hard thermosetting film, then the susceptibility of dirt and mildew is much reduced. That soft surface simply isn't there for any mildew to grow on. Also, as you can see on the slide, well-applied powder also delivers a nice uniform visual appearance regardless of orientation, unlike liquid coatings where it can vary between horizontal and vertical surfaces.
As well as many technical advantages, powder coatings can really deliver some great application advantages. Often, especially on aluminum, powders can be a single coat system, which makes it quicker, makes it more efficient, and also more cost effective to apply, especially when you compare it to 2 or 3 coat liquid systems. Some of the more common exceptions to this rule would be if you're working with steel, where usually we would say a powder primer and then a top coat can be used to protect against corrosion issues that sometimes are more common with steel. And also sometimes for seacoast applications on both aluminum and steel, where again, a zinc-rich powder primer might be used after pre-treat before the top coat to help protect against salt-based corrosion worries. Powder is also pretty easy to dispose of, especially when you compare it with liquid systems, where because of the solvents in liquid paints, all sorts of rules and regulations apply. Probably the best advice here is to check with your local government agency to find out what landfill requirements exist, just in case there's something special like perhaps requiring powder to be fused. But generally, powder can be disposed of really simply, really easily, doesn't create any toxic waste. It's easy to get rid of, very simple to do. There's nothing toxic in powder coating, so that means that we don't create any toxic sludge, as it said. So that's in either manufacture or in application, actually. The cost can be significant, and the time involved in dealing with toxic sludge are removed from the equation with powder. The lack of solvents or toxic components in powder also make it pretty safe to transport and store.
This lack of solvents or VOCs leads us nicely to the environmental advantages. No solvent means no permits required like with liquid paint, but also an advantage that many people, especially in the design community, are really interested in. When we at IFS got our environmental product declarations or EPDs, there was an enormous amount of interest from architects and designers trying to reduce the number of solvents used in their projects. There's a lot more on this slide, and it's really an impressive list, especially when you compare it to other types of coatings. You can see them all here. No toxic compounds like lead. The overspray of most products can be reclaimed and then reused or recycled. We do not create any toxic sludge, and those single coat applications use less energy and mean that powder has a significantly better carbon footprint. Powder is also extremely safe to transport and store. There's no special flammable rooms required, and it's also safe to work around. For these reasons and more, it's recognized and recommended by the Environmental Protection Agency and can generally help a company or a customer deliver on their own sustainability initiatives. You'd be surprised at how many people aren't aware of these environmental advantages, so please spread the word.
All right, thanks, Jason. So now let's look at the different types, product types, or chemistries, technologies, whatever you want to call them. They get called different things all the time, that powders are available in. And it's probably worth saying here that there are different types of powder, and we're going to cover some of the most common here. We'll look at their general advantages, disadvantages, and suitable applications. Obviously, some will have different cure times. Some will be able to be low or fast cure products. Some may need longer in the oven. But every single one of them will come with a technical data sheet, a TDS, and make sure you get that, and whatever is correct on that TDS will give you all the information that you need in that respect. All right, so let's start with standard polyesters. I think these are probably the most commonly used powder coating, and that's for a pretty good reason. They're a real workhorse, they provide great value for money, and they're available in an enormous range of colors and special effects. At IFS, we actually have over 55,000 colors in our database, and pretty much every single one of those is available in the standard polyester chemistry. So as well as the general advantages that powders bring to the table that we just discussed, standard polyesters will also deliver pretty good chemical resistance. Many will meet and exceed the performance requirements of the architectural specification ARMA 2603. This is company dependent, so maybe check that out with whichever powder company that you use. And standard polyesters also deliver good overbake resistance. They don't yellow much if you do happen to accidentally overbake them in the oven. Standard polyesters are also available in formulations that include TGIC in them, and those that they don't include TGIC, but are known as TGIC free, or sometimes they're called primids as well. And we're going to look at the differences between TGIC and TGIC free formulations in a moment. But standard polyesters can be formulated to be fast cure, which some companies also call low cure. This type of formulation allows you to either turn the temperature on your oven down and still achieve full cure, or, as is more common, leave the temperature as it is, but cure the powders more quickly, which then obviously allows you to improve the throughput on your line. So generally, they're a pretty effective powder coating.
And to kind of expand on that, sometimes fast cure to speed that line up on a nice thin piece of metal is what you want, but sometimes you have that heavy, thick piece of metal that you don't need to be in the oven for an hour, so you go to a low cure product, so you're only in there for 20 or 30 minutes. So as with all things in life, there's also some disadvantages to these powders, the main one being its weathering capabilities. While standard polyesters do have some basic weathering capability, you can expect them to retain their color and gloss to within a reasonable level for 1 to 3 years. They do not have the superior weathering capabilities of other powder types, which we will look at in just a moment. So for items permanently outside, you may want to question if this is a suitable product or whether a powder with better weathering capability might be more suitable. And depending on the polyester and its cure level, you can also see some orange peel with standard polyesters. Again, which type of product it is will make that more or less. However, it has to be said they are still regarded as the workhorse of the powder world, and you will see them on many different applications, including interior furnitures, retail store interiors, conveyors in manufacturing facilities, just general industrial components, even interior lighting, and the list goes on and on.
All right, so let's move on to a different type of polyester. It is a type of polyester, but it's called a super durable polyester. Super durables, as the name suggests, are designed to have better weathering capability and be more durable than the standard polyester. So super durables will offer great mechanical and chemical resistance performance and some pretty impressive weathering too. For many super durables, and again, this is company specific, but it's certainly true at least here at IFS, our super durables will meet and exceed the performance requirements of ARMA 2604. That means that you're going to see color retention to within 5 delta E units for well beyond 5 years, probably more like 10, and a minimum gloss retention over that same time period of about 30% or more. So in fact, we actually warranty our super durable powders for 10 years when they're applied by a registered applicator to aluminum. You're also going to see pretty good humidity and corrosion protection with a super durable. For example, standard polyesters only have to pass 1,500 hours of salt spray and humidity testing. IFS super durables will easily pass 3,000 hours of salt spray and humidity testing, so twice the amount. So great for any kind of corrosive or humid type atmosphere. Like standard polyesters, super durables are also available in TGIC and TGIC-free formulations and can also be manufactured in almost as many colors and effects as a standard polyester. So all of this actually makes super durables excellent value for money, as often they're only slightly more expensive than a standard polyester, but they're going to deliver significantly better weathering performance.
So it has to be said that there aren't actually too many disadvantages to super durable polyesters. They may have a slightly lower impact resistance than a standard polyester, and lower fast cure formulations may not be as readily available, but they are still available. Some may say that they are more expensive and therefore this is a disadvantage. And it's true that they are slightly more expensive than a standard polyester, but the significant improvements in weathering capability that they bring over a standard polyester actually make them a pretty good value for the money, especially for exterior applications. As a result, you're going to see super durables used extensively on exterior applications, on everything from commercial storefronts, for like the front of stores like a Subway restaurant or a McDonald's, lots of your aluminum windows and doors, as well as exterior patio furniture, farm equipment, and heavy-duty trailers. We've actually had several customers, using standard polyesters on their products. But once we introduced them to the additional performance of the super durable, along with, some other issues they were having, they found that they got better transfer efficiency out of the super durable. They got a better product. And in the end, the slight increase in price was very minimal. They readily took that slight increase in price for the performance gains that they made.
All right, awesome. So we've mentioned as we've gone through both standard polyesters and super durable polyesters. We talked about TGIC and also TGIC-free formulations. So what is TGIC? And I'm kind of upset that I'm the one that has to say this because it's a mouthful. But let's give it a go. So it actually stands for triglyceridyl isocyanate. Hopefully I said that right. TGIC is so much easier to say. That is a bit of a mouthful, so that is why it's TGIC. It's actually a cross-linker that can be used in a polyester-based powder. TGIC is not allowed in European coatings. So that can be an important consideration if you're doing work for European customers or people that are used to dealing with European coaters. TGIC formulations are allowed here in the USA and North America, and both TGIC and TGIC-free powders are widely used. There are a few differences. For example, TGIC can actually give a better first-pass transfer rate than a TGIC-free formulation. And for this reason, we often see TGIC-free formulations used where first-pass transfer is extremely important, like with wire goods, that type of thing. However, TGIC is more sensitive to excess film build. It can have less overbake resistance, and it can also outgas more easily than a TGIC-free formulation. The good news is that both generally perform well. None of the chemical, mechanical, or weathering functionality is lost by choosing one over the other. So they're both a good option.
All right, let's move on to the next type of powder coating, which will be our epoxies. Epoxy powders are very common. They're actually the first types of powders to be used commercially. Epoxy powder is really known for its first-class hardness and chemical and corrosion resistance. In fact, in terms of chemical and corrosion performance, epoxies offer the very best protection of any type of powder. The solvent rub test on epoxy is first class compared to the other chemistries. They also have great adhesion properties. So all these factors together, along with the ease of application, mean that you many times will see epoxies used as primers.
As Jason says, epoxies have incredible corrosion and chemical resistance. However, they do not have good weathering capabilities. And this means that they have to be used on interior applications that are not going to face any type of exterior exposure. Or as Jason said, they're used as a primer to deliver that awesome substrate protection, and then a top coat powder with better weathering performance is added, on top as the top coat. We see epoxies used as primers on heating, ventilation, and air conditioning equipment, as well as heavy off-road equipment, and also often on interior pipes and as primers, oh my goodness, all sorts of different applications.
So the next type of powder we want to talk about would be the urethanes. Urethanes really aren't as common in just general applications, but they still have their place in the industry, and they're definitely worth mentioning. So as you can see, chemically, urethanes are very similar to polyesters. The main difference is the curing agents that are used. What urethanes bring to the party is incredible smoothness. They are very good looking powder coating finish. They have an excellent exterior durability and chemical and corrosion resistance as well. So far, so good. They seem pretty perfect. So let's hear why we don't actually see them and use them as often as we do, despite some of the great characteristics.
Well, I think probably one of the main reasons is probably the cost. The resin is pretty expensive, which makes the cost of the overall powder coating itself expensive too, especially if you're going to be using it as an everyday powder. You can also see urethanes outgas and become brittle at higher mill thicknesses, and a strong odor and even smoke can sometimes occur with urethanes. So if you are using them, keep an eye on your application and your cure parameters. We've seen urethanes used on items like fuel tanks, get used a lot in domestic appliances, I think, where they want a very smooth and chemical resistant film. And they're sometimes even used on wheel rims and doorknobs. Jason, you got anything else you want to add? Because I think you have some experience with
I think in the job shop area, in the custom wheels and stuff like that, you really see a lot of urethanes because they do flow out extremely smooth. They do give you the good, the great gloss and the DOI. So, we see that in a lot of the custom work that's going to have external use.
Cool. Moving on.
I guess our next combination of powders would be our what we normally term as hybrids, but in most cases it's actually an epoxy-polyester hybrid. So for this example, let's just look at the epoxy polyester, which is a fairly common form of the hybrid powder coating. It's a mix of epoxy and polyester resins, and the main advantage of this type of hybrid powder is it's a little more economical to make. Therefore, it's a little more economical in pricing. But the combination of the resins can make them comparatively cheap. In terms of performance, adding the polyester helps with overbake resistance and can help with smoothness, especially at thin film levels. However, there are some significant disadvantages that really need consideration.
Yep, the disadvantages of this type of powder mean you need to be careful when it comes to what you're applying them to. As we mentioned before, epoxies have excellent corrosion and chemical resistance, but no weathering capability. And whereas polyesters have a reasonable level of weathering capability. Mixing the two together actually reduces the corrosion and chemical resistance of the epoxy, but unfortunately, it doesn't add much in the way of weathering. So with that in mind, this type of epoxy polyester hybrid tends to be used on items that need thin films and very good cosmetic appeal, such as indoor appliances, shelving, interior lighting, power tools, and refrigerators.
So the final type of powder we're going to look at today is the fluoropolymers powders. Fluoropolymers are mainly used in the architectural world and are nearly always used on exterior applications because they are known for their beautiful aesthetics and their world-class color and gloss retention. As well as color and gloss, they also display incredible corrosion and humidity resistance over properly pre-treated aluminum. There are two types of fluoropolymers, PVDF, which stands for polyvinyl iodine difluoride, and FEVE, F-E-V-E, which stands for fluoroethylene vinyl ether. The most common form of PVDF is actually liquid paint, though some powders are also available in the PFDF formulations. PVDF is always a two-coat system, as a liquid on aluminum and even as a powder. They always need a primer with them. FEVE powders will deliver the same or better performance as a PVDF on aluminum, but in a single coat with no primer required. In terms of exterior performance, these powders are really very good. They're also very easy to apply because of the resin-rich formulation, and they're being used on very high-profile architectural projects all over the world. The tall skyscrapers that you see going up in all the major U.S. cities and expensive windows and door systems all use the fluoropolymer powders.
Yeah, and I actually spend a lot of my time in the architectural powder world. So I deal with fluoropolymers a lot. As they compete with the liquid coatings that are used on these expensive building projects, then just like the liquid paint, a warranty is often required with a fluoropolymer powder coating. Most coating companies offer the same deal. They provide a warranty for certain aspects of the coating to the coater, and then the coater provides a warranty which may include other aspects to the project owner. So because of this, fluoropolymers are only available to registered applicators who have to have a certain standard of pre-treatment, application, and oven equipment, and they're put through rigorous testing to see if they can apply the powders and meet the required standard. Also, the coater has to be willing to take on the financial responsibility of offering a warranty to the project owner. And that's generally not something to be taken lightly, especially when we're talking about huge, billion-dollar buildings. Finally, because fluoropolymers have such great exterior performance, they have a lot of fluoropolymer resin in them, and that resin is expensive. So fluoropolymer powders are one of the most expensive types of powders out there. Most commonly, they're used on curtain wall and building facade, windows and doors, that type of architectural exterior application. In fact, the skyscraper you can see on this slide has IFS 500 FP, the IFS fluoropolymer, on the facade of all 114 floors.
That's a lot of powder. So there you have it. We've been through some of the most common types of powder coats, and all these powder types are available in high quality formulations from IFS. Each powder type has various advantages and disadvantages, as well as quirks in terms of application or curing and suitability to different end-use products. If you come across problems or issues with any type of powder, you can check out ifscoatings.com and download our free ebook. Check out the videos and blog guides that are on there, or talk to your powder rep for advice.
All right, so let's address some of the common questions that we get when we give this presentation, Jason. I'm going to read you out some of the questions that we get in, and then I'm going to let you answer if that works. Okay, so the first question is, I don't want to go all out on a fluoropolymer. They're kind of expensive. So what's the best type of powder for exterior weathering?
So the second standard to the fluoropolymer would be the super durable. Obviously, it's more of a normal powder like a polyester, but it does carry the 10-year gloss retention and things of that nature. And with that, a urethane is probably not that far behind a super durable. It's just not as common and readily available as what the super durable is.
Is it a little bit more expensive as well? Or?
Yeah, they tend to be, basically because we don't have urethane sitting around in stock. They're just, they're more of a custom batch, whereas the super durable is more common to have readily available.
Okay, cool. All right, so the second question is, are there any common application issues when applying hybrids or urethanes?
So really, hybrids are normally very good application type products, and we've done some work with them to where we can get the film builds down quite low for the appliance market and the interior shelving market. So normally hybrids are a very good application. Urethanes, that's a little different story. We tend to get things like people call window framing, things like that, where you build up around the edges a little heavy. They do apply good. It's just sometimes they apply too good, and it causes us some visible issues that we have to take care of. If you get them a little too thick, you see a little bit of that outgassing, like a micro pop or a solvent pop would in a liquid. So you have to be a little more particular with the urethanes.
All right. And we're actually going to address some of the appearance issues that can come up, and also the application issues that come up in other webinars. So maybe watch out for those, and we'll take you through some of the ways, some of the common appearance or application issues that can occur, what to look out for and how to prevent them, and then maybe what you can do to control them if they do occur. So I think that's it for this webinar. Hopefully that was useful for you. If you need any more information on the different types of powders, there's a lot of information on our website, which is ifscoatings.com. And also, if you do have other questions or something that we haven't covered here, feel free to email us in. It's coatingsinfo@ifscoatings.com, and we'll get one of our technical experts to address those questions and concerns that you have. So thanks very much for listening, and hopefully we'll see you next time.